All right, so I just wanted to go through the note here. Hopefully it won't be too long, but basically we're talking about factored form. And so you got your standard vertex and factored form. And yeah, factored form is great. We've done a little bit of factoring last week. So hopefully you can kind of put stuff into factored form. If not, I'll have a little recap of that tomorrow when we're doing that as well. But here we go. We're looking at this. If you throw something in Desmos, yes, you could see it, but how do you get that without Desmos? So basically, you look at your equation here, and 1 second, sorry, of course, my little writing pad is not working at the moment, so it'll click in here, hopefully, and be good to go. But yeah, we remember that x always lies, and so when you see x minus 1 and x minus 3, remember that those basically are x-intercepts of positive 1 and positive 3. And then the axis of symmetry would be halfway between that. We know that these parabolas are symmetrical, so the axis of symmetry is like the mirror between the two. So when we have a point on each side, like our x-intercepts, 1 and 3 here, we know it's halfway between that. So we can kind of assume that it's going to be 2, but just to confirm how you do this in the future, remember, you just take the average. So you go 1 plus 3 divided by 2, that makes 4 divided by 2, and yes, it is 2. It's between 1 and 3, which is 2. Now, how do you figure out where the vertex is? Remember, if that's your axis of symmetry, your vertex is the point at the bottom. And so, basically, all you need to do is put in x equals 2 into our equation to figure out what the y is, how far up or down, right? We know that this is a point, 2, and then y. And so what is that y? Well, you put it into our equation here for x. So instead of x minus 1, it's 2 minus 1. Instead of x minus 3, it's 2 minus 3. And you will get 2 minus 1 is 1 times negative 1. You're going to get negative 1. So basically, our vertex is the point 2, negative 1. And then the y-intercept, instead of putting in where the axis of symmetry was, the y-intercept is always x is equal to 0. So you're going to go y equals, instead of x, 0 minus 1, and then 0 minus 3, and you'll get negative 1 times negative 3, it's a negative 3, sorry, which is positive 3. So that's your y-intercept. Didn't really need it in the brackets there, just 3. So that would be your y-intercept. So you can figure out the x-intercept, the axis of symmetry, the vertex, and the y-intercept, all from just looking at an equation. And we would then use that to graph this function again. That's what we'll do tomorrow. Here's another example. So x plus 2, x minus 4. Remember, x always lies. And so you're going to get 2 x-intercepts. Instead of plus 2, it's going to be minus 2. Instead of minus 4, it's going to be plus 4. AOS stands for axis of symmetry. And basically, again, remember, you are just going to add those 2 points together and divide it by 2. So that would be negative 2 plus 4 is 2. 2 divided by 2 is just equal to 1. So our axis of symmetry is 1. If you're good at kind of picturing a number line, you might have been able to see that as well. 1 is halfway between negative 2 and 4. Then remember, to find your vertex, you just put that number from your axis of symmetry into your equation. So 1 plus 2 instead of x plus 2, and 1 minus 4 instead of x minus 4. And you're going to get 3 times minus 3, which is negative 9. So your vertex is 1 minus 9. And then your y-intercept, again, remember, that's always when x equals to 0. So you're going to get y equals 0 plus 2, 0 minus 4, and you're going to get 2 times minus 4, which is minus 8, your y-intercept. All right, so feel free to go back and pause to be able to get any of this down that you need for your note here. But your practice is going to be telling me the x-intercept, axis of symmetry, vertex, and y-intercept of these 3 equations. Make sure you check your answers with Desmos. And then there is 3 practice questions here with solutions as well. So please go ahead and answer those questions there, and feel free to reach out with an email if you have any questions.